Okay, here we are in the configuration mask of Darwin. I've zoomed it in so that you can see the entire thing much better. We have a center line in the waterfall. The waterfall display is showing us the stability of the system timer as it gives you 40,000 interrupts per second under current settings. If you were to have a large timing problem, you would find large blue areas on the outside. If you get that, feel free to send me a snapshot. I can often tell you more about what's going on with your system if I see this particular statistic. Obviously, this slider bar selects our pulse frequency, and the second I move it, you'll see it adjusts very closely to the selected frequency. It also snaps into the nearest 1,000 just to round things off so you're not using weird numbers. As in Mach 3, I recommend using as low a number as you can, which will drive your motors at speed. That allows lots of CPU time for Mach 4 to do its thing. If you find that your system is not being hogged, feel free to slide the pulse count up even higher and reconfigure your system. It will make your pulse train a little smoother the higher it is, but not noticeably so for many, and not at all for most servo users. Servos have their own way of smoothing out pulse train inconsistencies. We have a time and interrupt, which you'll see is 3 microseconds at the moment. If this hits 15 or 20, you're in trouble, and you're probably trying to do too much in your interrupt. When it hits a value equal to the reciprocal of 40,000, in this case, you will crash. Blue screen of death. Hasn't happened to me yet. I've slid mine up to 100,000 and it's worked, but don't take that for granted. I would keep it as low as you can for your motors. We have 2 versions on the screen. You'll notice it says version 1.08 and version 1.09 in this video. That means version 1.08 is the hardware driver, the sys file, which was loaded into your device manager. 1.09 is the DLL, which is the marshalling program, which allows communication between a Mach 4 plugin and the sys file. It also controls this diagnostic and configuration pages. You should check the Mach4 threads just to know what the current versions are, or write me an email and I'll let you know what they should be currently if you suspect that you're having a problem. Some people, when they update their hardware driver, it doesn't always work. Some systems remember where the old one was and loads it instead. So sometimes this bottom number 1.08 is very important to know after an update. Let's go to ports control. Here you can see we have a picture of a printer port, and the pins, the color on all these dots around the pins are the real-time condition of those pins. So if you're to feed something in or press a home switch, you can always check it here if it's whether you've got it configured or not, because if it's on a pin, it'll show it in real time. This is before we ever get to the input stage to load input variables. This is a real-time monitor of the printer port itself. So here we select the port that we wish to enable. You can see I have one enabled here at 0xD000. Make sure that you know your hex address. If it's wrong, you could blue screen to death. That's because Darwin does not talk to printer ports, it talks to hardware ports. It doesn't know what it's talking to until you tell it where to go. So you could set this port so it accidentally talks to your video card, for example. And God only knows what happens when you try to step and direct your video card. If you get a blue screen to death, typically you can go back in and reset this, because it will not have saved the enable this port check button. When you check the button to enable a port, you'll be asked the question, is this okay? And the reason it's asking you that question is to impress on you that a wrong address could be the cause of what's about to happen. We have an e-stop button here beside us. Mach 4 demands that you disable motors before going to configuration. And in Mach 4's parlance, disable motors is the same to Darwin's thinking of an e-stop. So when you come in, it'll be red and e-stopped, and you won't be able to jog motors in the further screens unless you push this to turn it green. If you have an e-stop button set up, you can test it, because if you set it up on the inputs, trigger it, this this e-stop will then automatically turn red. It is not the responsibility of Mach4 to respond to hardware e-stop. It's the responsibility of the system timer. So it will turn red. You may have to come back and press it green. If you push reset and it won't go green, it means that you have an e-stop condition coming into one of your inputs. So turn off that input and you'll be able to reset. You can turn on up to 4 ports. Keep an eye on your time and interrupt. Don't allow it to go above 15 or 20, or you'll get to see that blue screen of death we've been talking about. Now let's go to motor configuration. You can have up to 9 motors. At the moment, you are only allowed to put 4 motors on. Mach will not talk to more than 4 at the moment. You can enable the motor. Just check the enable box. Any settings that you do here, all of these settings are instantaneous. If you check enabled and then exit, everything is done. The motor instantly becomes enabled and you can jog it and so on once it's set. So be careful what you do here until you've set your pins. Here you can see I got port 1, pins 6 and 2 set. You can negate the direction or step signals here if you wish. You'll notice a slider for jerk reduction. This is only used in operations such as homing or probing. Darwin's internal jog translator is a high order jog. You have a jerk reduction. This will not affect your performance in Mach4. It's only for homing and probing, which are cases where Darwin handles the jogging itself. Same thing here with homing and homing speed. These are not the homing speeds that Mach4 uses. These are homing speeds which Darwin is capable of internally and may be used at some point in future. So you can ignore those for the moment. Acceleration, same deal. You can set the acceleration, but in the end, Mach4 will control that. This acceleration and jerk reduction, however, is used in homing. So set an acceleration which you figure is appropriate for homing. Normally, when you're homing and probing, you're moving fairly slowly, so these won't have great impact on you. But you can test them if you slide your jog speed maximum up, and that's this slider over on the side. This is in hertz. So just take it up maybe 10 or 20% of your maximum kernel speed, and you should be able to then click in this jog ball and jog your axes. And you can see when I do, we get a green light under jogging to tell you that the system has sensed that a motor is jogging. You'll see the index value change, which is the main counter index in steps for that motor that you have selected, motor 0 in this case, and you'll see a velocity showing that that's how fast the motor is going at the moment. And you can change the effect of this jog ball between axes by selecting various axes. Again, we have a time and interrupt. Monitor that you're not using too much of a time, but usually that's not a problem on this screen. And that's pretty much it for setting your motors. You can set them all up, test their motion. If you find them smooth in Darwin and for some reason they're getting choppy in Mach4, it may be that the CPU on your system is eating so much CPU that Mach4 can't feed Darwin fast enough. Then we have input signals. In input signals, your first 2 signals are locked. You cannot rename them. Emergency, which is your emergency e-stop button coming in, is always signal number 1, and signal number 2 is always a probe. That doesn't mean that that's pin 2. The signal numbers are totally independent to what pins or ports you use to connect them to. You'll see that on the 3rd signal here, for example, I have home Y. If I select it, it says home Y and it's signal number 3. You can type in any name that you wish for any of these signals and it will be remembered, and in Mach4 when you're configuring it, this is the name that will come up when you go to map a signal. You can set the port and pin for what this signal will be. In addition to enabling it, there are some selections which you should ignore. There is mux low and mux high. This is for multiplexing signals. A single printer port can actually have more signals because it can share any pin with 2 signals, but that's for advanced users, and until such time that some breakout board can take advantage of it, there are only a few plasma type boards which can at the moment. You should leave mux unchecked and turned off. Signal negated is up to you. If signal negated simply means that you're going to put out a high or a low when it's active. Normally a signal when it gets activated goes high, so it'll put out 5 volts. If you want it to be high when it's not active, then you'll use signal negated. E-stop trip. Any signal can be flicked to e-stop trip. All that means is when this signal is seen to go active, trip and e-stop and shut the system down. You can turn that on for any one of the 128 signals that you have set up. And again, don't be fooled by the position of the signal. Just because signal is signal number 3 doesn't mean that it's using pin 3. This is port 1, pin 11 for this particular signal number 3, for example. In Mach, you won't have to worry about the signal number. In Mach4, you'll always be presented with the names that you've entered. So at the moment, the only ones I have named is emergency, probe, home, X, Y, and Z. All the rest are undefined, or I have nothing entered. You can have a debounce. In the debounce, you can say how many interrupts before this signal will be considered real. Much like Mach 3, only in Darwin, every signal has its own debounce. So if you have one signal coming in and you know that that one is particularly noisy because it's on a very long wire, you can debounce it without affecting all the other signals. That's pretty much it for input signals. While you're on this screen, you'll again get the time and interrupt. Won't be too important to you here. But you'll also get this signal current status. It will either show green for active, red for not active, and yellow if it has a frequency on it. An input coming into Darwin can also be measured as to frequency. This is one way that you could, with a very small amount of external signal, circuitry, you could feed up to 100 signals really into Darwin, because you can feed in a frequency and use that as an analog value. Output signals, same type of deal. We have 128 signals. The first 4 signals are your charge pumps, and you cannot, although you can enable and disable them, you cannot change them from being the first 4 signals. The next signal I have named as enable on my system. I'm using that as my enable to turn on my servos, port 1, pin 1 in my case. You can see again you have mux selections, and until such time as somebody's using mux, leave them off at the moment. Negated, of course, is up to you. You'll also see a current status of frequency. This is an output signal, and there's a box here for setting its frequency. Any output signal can be set to a frequency. For example, let's take a look at my spindle, because that's where we would use it the most. I have my spindle signal enabled, port 1, pin 16, and you'll notice I have a frequency entered, 12,500. This is because I'm going to use my signal in this particular case as a PWM, pulse width modulated spindle output, rather than an on-off selection. To do that, to inform the plug-in that this is actually used as a PWM instead of on-off, I've entered a frequency into the frequency box. It's not really important what number you add in the case of a spindle, because your S word in the end will control the frequency. But for any other signal, you can have a signal. Let's create one, and I'll show you what I mean here. Let's go to one that we haven't used, and let's call this warning. So I'll enter the name warning, I'll enable it, I'll set it to pin 14 arbitrarily, and I'll give it a frequency of 4 hertz. Now I have a toggle button for diagnostics, so I can toggle that signal on. And you can see that now it's telling me the signal is yellow at 4 hertz. That signal, for example, if Mach 4 had said turn on, the signal is now putting out 4 times a second, toggling at 4 times a second. So if you had a light on it, you'd have a warning light flashing on your gantry at 4 hertz. That's one use for a frequency signal. If you enter 0 in the frequency box of any output signal, it will just be green for on or red for off. And so for most of your signals, you'll have 0 in the frequency, the exception being your spindle. If you're going to use a step direction spindle or a PWM signal, you want to enter a frequency here. And I'll explain when we get to the Mach 4 part how you then use it as a step direction or as a PWM spindle. Now, if you're going to use a step direction spindle, that's implying that you have a separate line for spindle clockwise or spindle counterclockwise. So you would want to go to turn on another signal, and you can pick any of the 128 signals, set it to a pin, and name it spindle counterclockwise, for example. Once you do that, it's remembered in the system as spindle counterclockwise, and you would not put a frequency. You would just leave it as spindle clockwise so it can turn on or off to signal to your servo drive that you're going to go counterclockwise, obviously. Soft limits you do not need to use. You can just leave them at their defaults because Mach4 has its own soft limits. Darwin has them built in as well, but they're not used. They may be someday in the future, who knows. Encoders, you can have up to 12 of them. They're numbered 0 through 11 because typical to programmers, I consider 0 a number. Some people do, some people don't. Encoder Zero is my first encoder. You can see I've enabled mine and set the A and B signals to my printer port. Now, if I had an encoder on here in front of me at the moment that I could spin, you would then see the frequency at which I am spinning it, because encoders, all signals are actually measured for their input frequency, whether you display it or not. And then we have a time and interrupt. The reason my Encoder Zero is enabled is that I'll be using it on my system as an MPG, and if you want to use MPGs, you're going to have to turn on one of your encoders at least, and you can use any of the 12 encoder inputs as MPGs. At the moment, Darwin is limited to one MPG, but the rest will be turned on as soon as everything else is done. The About page simply lists the maker of the software and a picture of Charles Darwin. Some have accused me of being in that picture, and although I do look similar some days, that's actually Charles Darwin. So that's it for the configuration of Darwin on its main screen. The rest we'll deal with inside Mach4 itself. Okay, so here we are on the Mach4 side, and to start with, when you begin Mach4, create a profile for Darwin. I called mine Darwin Mill, whatever you like. And then the first thing you're going to select is Configure Set Motion Device. Do not push the Enable button. When you do, none of these buttons will work, so select Motion Device first. And you can see in my case I've selected Parallel Port Device, the simulation, and I have the Ethernet Smooth Stepper plug-in here, so it's also there as available as a checkbox. So we'll select the printer port device, and then we're going to configure Darwin, as we just did in this video. But in order to get there, we would go Configure Plugins, and here you can see all the plugins in the plugin folder, and Darwin is enabled with a checkbox, and you configure it by pressing this Configure button, and that would take you into Darwin. When you're finished your configuration, you're back to this box, and that would have represented the previous part of this video that you've watched. And then OK. So at that point, we've configured our inputs. I've set some home X, Y, and Z switches and so on. So let's look at how we configure Mach, which is the third selection, to deal with that. These are your Mach standard settings. Set them for whatever you like. When you go to motors, here you will set your counts per unit, velocity, and acceleration. The rule for Darwin is if you have a kernel frequency set, take your velocity in units per minute, divide it by 60, and multiply by counts per minute, and that must be less than your kernel frequency. If it isn't, once you're finished configuring and hit OK, you'll get an error in Darwin or in Mach4 on the status line, which is a message from Darwin telling you your axes are tuned too fast, and it will tell you what your maximum should have been. So you'll set your accelerations and your velocities here. You cannot move your motors to test what you're setting, so you'll have to set them through a trial and error. Hit apply, and now we'll go to axis mapping. Here on the axis mapping, you'll turn on the motors that you've turned on in Darwin. If you don't have it turned on in Darwin, do not turn it on here, and similarly, do not turn it on here if you don't have it turned on in Darwin. It will cause motion errors for you, and it will trip the disable down here after homes and so on. So you should have X, Y, and Z set, and they should all be set as what their master is. So basically you're matching a motor with an axis. So on my case here, you'll notice I've got motor 1 going to the X and motor 0 going to the Y, and this is because I'm using a Cartesian machine which I have turned sideways to me, and I wanted my axes reversed to the motors. Anyway, that's where you control these things. Under homing and software, here you will set your home speed and your home offset distance and your home orders. So, and your home direction. So I'm telling it to home my X and Y axes in the negative direction. Do them both at the same time because I've got them set to a home order of 1. Once they home, they'll be considered 5 millimeters away from home. Under homing here, when you hit home, the axes will move to the switch, will stop on the switch, and set 5 into your register to tell you that you're actually -5 away from home. If you then hit go to 0, you'll be at your proper home location. Darwin and Mach4 do not move it off of your home switch once you hit your home switch. You'll notice the Z-axis, because I'm going to be driving a laser, I don't have a Z carriage, so I've got it checked as home in place. So when you push home or try to reference your Z-axis, it will assume wherever it is at the moment is home for your Z. Now for input signals, this is where I have to turn on a couple that we turned on in Darwin. And you'll see I have motor 0 home, and I'm going to select Darwin as the device and home Y for my motor 0. Those were previously set and the system forgot it. We've got a small software problem going on somewhere at the moment, which is sometimes erasing settings. That should be all fixed up by the time you've played with this, but this is where you set your home switches, and whenever you're mapping an input to Mach4, you select the device. Once you select the device, what shows up is all the switches that you have activated in Darwin. If you've enabled it, it will show up here by name as the name that you have given it. So in this case, motor 0, which is my Y-axis, is going to use my home Y switch, which makes a great deal of sense. Output signals. The only one that I'm really using at the moment is enable. I have it set to Darwin, and again, you'll get all of the output signals that you can use listed. And in this case, I want that one for enable. And that's enough in my case to deal with it. But for those of you with PWM and frequency step direction spindles, this is where on the spindle page you'll set your minimum RPM and maximum RPM of what you're going to get for a PWM signal. In other words, when you do an S word and you're sending a PWM signal to a spindle, PWM goes from 0 to 100 as 0 to 100% duty. So this is your 0 and this is your 100. If you were to type S5000 and you have it set to 5000 RPM maximum, then S5000 will give you a 100% PWM signal. And that's pretty much it for the settings there. But we have another one under diagnostic reg file. You'll find an entrance for Darwin, and Darwin holds a few extra variables for you to set. If you're using a step and direction spindle, that's implying that you have a frequency driven spindle, and this is your frequency that's low and your high frequency for that spindle range we just talked about. So in other words, if you have a 0 to 5000 RPM spindle and you type S5000, if it's a frequency spindle, you're going to want to know what frequency to send out, and the system will send a 4000 hertz out if you were to go S5000 because you're at 100% of the range of the spindle. If you were similarly to slow the spindle way down, it will range it between the 400 and 4000, but it will always give you 400. This is because some inverters need a minimum frequency. They simply can't go any lower. Step width is to allow you to add a few microseconds to your step width pulse. Your step pulse you could add 5 to 10 microseconds, but it lengthens the time that you're in the interrupt. So you should leave this at 0 unless you need it, and then inch it up one at a time to see if it makes your system respond better. You'll need it if you've got a system which is badly losing steps. You may want to bump that. If it's only intermittently losing steps, or sometimes a 1 bump will probably fix it. You can try it at 5 or 10 if you have a real rough system, just to see if that's the cause. If it isn't, move it back to 0, because this is a time waster. PWM spindle makes the determination between you have a PWM output spindle or a frequency spindle. If I set it to 0, this spindle frequency low and high is now active instead of PWM. This is only true if you've entered a frequency on your spindle signal in the Darwin configuration. You'll remember we had a box where we typed a frequency and I entered 12,500. By doing so, I told the system that that signal will either be frequency or PWM, and this setting makes that decision whether it's PWM, or if you set it to 0, it becomes a step direction. The next two is the number of counts in a detent of an MPG, and then MPG1's encoder number, which I've got set to 0, meaning the first encoder, the Encoder Zero in Darwin, should be considered to be MPG1. If you disable Encoder Zero, then it won't be you will no longer be using it as an encoder, or you can set it to -1 if you don't wish to have any encoder set to an MPG. Those are all the settings for Darwin and to set it up for Mach4. If you've done that properly, you should be able to hit reset, and you'll see I got a message from Darwin saying the home switch Y is tripped. If we go to the diagnostics page, X and Y are both tripped, and this is because my system is actually sitting on the home switches at the moment. Your buttons for jogging should appear and should work. If the buttons, for whatever reason, do not appear, it means that in the configuration for Mac, and again, you can't get there unless you disable the motors, go back to Mach, go to your motors axes mapping, and if this has gone blank, it means a bug has happened and they've been erased, and that's why you don't have any jog buttons. You can set them up again, and we're hoping for a fix in that anytime. All right, that's it. Have fun.